In this video, I'm going to go through how to calculate the Pearson correlation coefficient using the covariance formula that we see here up on the upper right-hand corner of our Excel sheet. And I'm going to focus on calculating the numerator first, and then we'll calculate the denominator, and we'll put those together to calculate the Pearson R using these fictional data. Now, these data here are a sample obtained from 19 university students who took an exam and scored, had a range of scores out of 100. And the objective here is to examine the relationship between the number of hours studied in preparing for the test and the eventual score in the test, asking if there is a correlation between how many hours students study and their eventual academic performance. So the first step I'm going to do here is I'm going to calculate the descriptive statistics, which is the mean and standard deviation for each of the two variables in question. So I'm just going to use the Excel command. I'm going to highlight the cell where I want to put the mean. I'm going to hit the equal sign. I'm going to type in average as the command. I'm going to Shift 9, open parenthesis, and I'm just going to use my mouse and highlight all of the data in the first column. I'm going to Shift 0 to close the parenthesis, and I hit enter, and I have a mean of 71.13%. To calculate the standard deviation in the next cell, I just simply hit the equal sign, and I type in the Excel function, or the Excel command, stdev. I Shift 9, and I use my mouse and I highlight the same data that I want to use to calculate the standard deviation. Make sure you don't highlight over the mean as well. Shift 0, I hit enter, and we have our standard deviation. Now, I need to do the same thing for the second variable study, but to make this quick, I'm just going to highlight the first cell where I calculated the mean. I'm going to grab the bottom right-hand corner. I'm just going to pull it over, and Excel pulls over the same equation, but inserts the next column to calculate the averages. You can see that up here in the formula bar. And I'll do the same for the standard deviation. I'll pull that over. The next step is to calculate the component of the variance score for each variable separately, which is essentially a deviation score for each variable individually. And I'm going to put that in right here in this first cell. So I'm going to hit the equal sign. I'm going to click the first observed data here, the first value, and I'm going to subtract the average value, which I have down here. Now I can type in this number, or I can just enter the cell number, but entering the cell number, I need to Shift 4, put the dollar sign for column B, so I'm going to lock in column B. I'm going to Shift 4 again, and to get the next dollar sign, and now I'm going to lock in cell 21, because when I use the option to pull the cell down for the other data, I don't want Excel to advance that particular cell to the one below it. I hit enter, and I have the deviation score of the first person from the average, and it's a positive value indicating that this person scored higher than average. So I'll highlight this cell, I grab the bottom right hand corner, and I just pull down to all the data, and now I have the deviation score for the first variable. Now to do the same for the second one, I'm just going to shortcut this. I'm going to highlight the first cell. I'm going to grab the bottom right hand corner, I'm going to pull it over, but notice that the dollar sign retained column B and row 21. I just need to make an adjustment to this and change the B to a C. And that makes the adjustment where this mean is now used in the deviation calculation for the second variable. And I'm going to grab the bottom right hand corner of the first cell here. I'm going to pull down, and I have the deviation scores for the second variable. Now the next step here is to calculate the product of the two deviation scores, and you see that here in this entry in our numerator. So I'm just going to hit the equal sign. I'm going to click this cell. I'm going to Shift 8, and then I click the next cell that I want to multiply, and I hit Enter. Now I grab the cell and I pull all the way down, where I then calculate the product of each entry for the deviation of the X variable, which is score, and the Y variable, which is study. And as you can see in following the equation, we need to calculate the sum of these products. And I'm going to put that value right here at the bottom. So I'm going to hit the equal sign. I'm going to type in the command, which is SUM, Shift 9. I'm going to highlight all the products here. And I Shift 0 to close the parenthesis, and I hit Enter. Now I have the sum of those products. Now I'm ready to go ahead and to calculate the full numerator and the full denominator that will be used to calculate the Pearson R. So I'm going to put the numerator value in here, and what I need to do is I need to hit the equal sign. I highlight the cell that contains the sum of these of the products of the two deviations, which I have entered down here at 92.69. And I hit the forward slash. I need to divide that by the degrees of freedom, which is n minus 1. Now, because I have a sample size of 19, I'm just going to type in the value of 18. So 19 minus 1 is 18, and I hit Enter. Now, to calculate the denominator, I just simply take the product of the two standard deviations, which I have because the first step was that I calculated the descriptive statistics. So I start with the equal sign. I click the first standard deviation. I Shift 8, and I click the next standard deviation, and I hit Enter. Now I'm ready to put this all together and calculate the Pearson R. So I hit the equal sign, I take my numerator, forward slash, and I click my denominator, and I have a Pearson correlation that is positive and moderate at 0.486, indicating that a greater number of hours studied is related to a higher score on the test, and that relationship is considered moderate at 0.486. The last item I'm going to do here is I'm going to use the Excel feature of the data analysis package to see how well my Pearson R relates to that feature in generating the Pearson R. So I'm going to go up to Data, go all the way to the right where it says, where I have the option Data Analysis, where it pulls up a number of options in this data analysis tool. And I scroll through, you see a number of options here. I want correlation. So I click correlation, I hit OK. Now I just need to enter in the array of cells that contain the data that I want to calculate the Pearson R for. And so now that I have my cursor that's highlighted, I can go to the original data, the raw data, score and study. Note I'm going to grab the column headings as well. Now highlight all of those and make sure to click this box here at the bottom left hand corner, labels in the first row, and it's going to carry forward the labels when it calculates the standard or the Pearson correlation coefficient. And I want to put my output on the same worksheet. The default is that Excel will open up a new worksheet at the bottom, but I want to put the output right here just so that I can make a visual comparison between my manual calculation of the R value and what Excel is going to give me. So I click the output range that I need to specify. So I click this cell, click this the output range bar so that the cursor is active, and I'm just going to click this cell right here. I could have clicked any other cell, but I'm just going to put the output right here. Now that I have that set, I hit OK. And you see that a correlation matrix is generated. We only have two variables, so we only have one correlation coefficient presented. And as you can see here, the correlation coefficient is identical to the one that we had just calculated using the manual method in order to examine that relationship between these two variables. And this ends this video on using the covariance formula to calculate the Pearson R.